something called as formal language and automata. Okay, it was the basis of this paper, compiler design. So this is a very important paper. You have to learn it. Okay, uh, if you know a particular programming language, you should be learning how it has been done with the help of this paper. Okay, so you should be knowing compiler design very well. The second one is if you are going to try for higher studies, you will be getting the questions from this for your entrance exams. Many things from formal language and automata as well as compiler design. So you should be knowing at least how it is being done. Okay. So this is a basic paper you should be learning. So whatever we learned in the formal language and automata, actually it was covered in the first unit itself. Okay. So we have learned what is finite automata. We have learned DFA, NFA. We have learned epsilon NFA. We learned what is a regular expression, how the conversions have been done. All these things we have learned it in the formal language and automata. Okay. That was taken as the basics, and it was there in your first unit also. You can see it. I have just mm, so this is the thing. So you'll be learning about finite automata. Okay. So it has been continued in the syllabus also about NFA, DFA, epsilon NFA, and other things. It has been there. Okay. So the first unit mostly it will be easy only because you have already learned all these things in the formal language and automata. Okay. So, but in this first unit, we will be starting with the basics, why we have to learn compiler. So an introductory part will be there, and how this compiler has been implemented. There will be some phases of compiler, so that you will be learning in this paper. Okay. So that is the basic part. Okay. So then we will be moving on with the some of the basics about the finite automata in the first unit. Okay, so we'll start with introduction, then phases of compiler, then we will learn the basics for this one. Okay, so the next one, what I want to show is actually this is the phases of compiler. So you have lexical, you have syntax, you have semantic, you have code optimization, and you have a code generator. Okay, actually when we are saying, we will be including another one also, that is intermediate code optimization also will be there. Okay, why I'm showing this diagram is so each and every unit you're going to learn each and every part that has been available in this diagram. So you can see lexical analysis. So lexical analysis we will be learning in the first unit itself. Okay, how the lexical analysis been done, we will be learning in the first unit itself. Okay, the second part is about syntax analysis. Syntax analysis you will be learning in the second unit, how it has been done. Okay, and the third part is semantic. Semantic also you'll be learning here also little bit, and in the third unit also you'll be learning little bit. Okay, so the syntax and semantics has been combined in second and third unit. Okay, so this was the process. And the next one is, as I said before, this code optimization, there is something called as intermediate code generation. Okay, so that part will be handled in the fourth unit. That you'll be learning it in the fourth unit, how the intermediate code generation has been done. Okay, the last part is going to be this code optimization. So while we are learning intermediate code generation, we will be learning this code generation part also. So whatever I have shown in the diagram, everything you're going to learn. In between, I have left intermediate code generation alone, that you will be learning along with the code generator. So that will be coming in the fourth unit. Okay, and the fifth unit, it is going to be about code optimization. Okay. So the main motto of this paper, you are going to learn how this particular compiler has been designed, and each and every phase of the compiler you will be learning in each and every unit. Okay, so this is the thing, and you should be knowing why we want to learn this compiler paper, why there is so much necessity of this paper. So that is the basic concern, right? So why you have to learn this paper is, if you know a particular programming language, okay, you should be knowing how it has been compiled and how it has been showing you the errors, and how the final output has to be done. Okay, so that you always do, you will write a program, you will compile the program, you'll be getting some errors. If you get the errors, you will correct all those errors, and at the final part you will be executing the particular program. So this is how you are going to do. This is only about the front part, just you will give a program, it will compile, it will execute, and you will get results. So this is only about the front part. But we should be knowing how this particular language that we are typing, or programming code we are typing, how it has been processed in the machine, we doesn't know. Okay, so that we should be knowing, so that you can understand the programming language better. So that is the main thing of this paper. So you are giving with the language, okay, so how it has been converted to another language, so it can be understood by the machine. Okay, so the machine should understand what you are actually doing. Okay, I can just talk in any language. Okay, but why I am preferring with the English is, you should be understanding whatever I am talking. So there should be some common thing between you and me. So the same thing here, compiler, we are trying everything in a high level language. Okay, so we are giving all the inputs in a high level code. Okay, whether you're going to do it with a C, you're going to do it with a C++, or you're going to do it in a Java or Python, let it be anything. Okay, so let it be anything, but at the last you should be knowing, how it has been converted to a another language, that is low level language, that is that was understood by the particular mission. So this is the main part. Okay, and always what we used to do is, we will give a high level language and you will get an output. That alone is the front part. The back end part we are going to learn with this paper. Okay, this is the first objective of this compiler design paper. Second thing is, mainly why they learn this particular paper. Okay, when they have started with this programming language, when we move on to the history, we were starting with a Fortran or a basics. Okay, then we have come to C, then we have C++, then we have Java, and we have many languages. Okay, we know many languages that is available now. But if they know how it has been done, okay, how it has been done at the back part only, they can actually develop a programming language. If you want to develop a new programming language, okay, so you should be learning how this compiler is happening at the back. Then only you can design a particular programming language. Without that, you cannot do anything. So if you want to design a particular new programming language, this compiler paper has to be learned. So you should be knowing what is happening at the back end part. Then only it will be easy for you to design a particular new language. Also, there are some existing programming languages. So you will be knowing how it has been done at the back part also. Okay, how the compiler has been designed for a particular language in the back end part also. So that also plays a role in the case of this compiler design paper. Okay, so this is the main thing. So it's a very basic paper, and it will be very interesting paper. Okay, you don't have to worry as you have worried for FLA. This is a very easy paper, and the lab also, it will be very easy. Lab you can execute with the C, C++, or Java or Python, whatever languages you are preferring, you can do it. Okay, so it will be continued like that. So, and what is the book we are going to follow in this case is, always this first, in the reference you can see the first reference, Ullman only we will use to follow for this paper. Ullman and Ravi Sethi, this paper, compilers, principles, techniques and tools only we are going to follow. Okay, other references, you can also use it when you want to do a comparative study. You can go through the other reference papers. And today I will upload all the ebooks that I have it in the GCR. If you want it, you can just go through it. Okay. So whatever we learn in each and every unit, that we will be doing it in the lab. So lab also, it is parallelly it is going to happen. So in the case of lab also, it is going to be the same only. For example, since today was the first class, you are going to deal about the file handling operations. From the next class, we are going to start with the lexical analysis. Okay, how the lexical analysis will be done, that will be the lab one. Okay, then the second lab, it is going to be how you're going to convert the regular expression to NFA. For that, you are going to write a code. Okay, so it is going to follow like that. So lab 3, you're going to learn about NFA to DFA. Okay, so I don't have to say each and every week. Okay, so if you're going to learn something that week, that has to be done as a programming part in your lab. Okay, and then you'll be learning about the syntax analysis, that will be having a lab exercise. Then the third one, semantic and intermediate code generation, and the last one is code optimization. You can use any language you're comfortable with, but if you go through the internet, always you'll get the codes only for the C++. Try to avoid using C++ alone. Okay, try something new. You can change it as Java. If you know Java very well, you can try all the codes in Java, or you can try it with the Python. Okay, so till now I have said everything. Any doubts in this one? Anyone? No doubts?
No, ma'am. No,
Okay.
ma'am. No doubts.
Okay. And like FLA, you don't have to worry about this paper, because I have to say something. First unit you have already learnt in FLA, and that you have learnt it very deeply, so you don't have to worry. You know all the pros and cons of the first unit, so no issues at all. So in first unit, only you'll be getting two type of questions. One is phases of compiler. If you're not very comfortable with the problem, you can opt for the phases of compiler, or else you'll be getting in the next part, that is about NFA, DFA, and regular expression. That questions will be coming in the first unit. And the second and third, for sure you'll be getting only the problem. Second and third, for sure it will be getting only the problem. Okay, in the second unit you will be learning something called as top down parsing and bottom up parsing. Okay, so there is only two type of problems. So in second unit also it will be easy only. There is only two type of problems. One is going to be top down parsing, another one is going to be bottom up parsing. Okay, you can see here it is going to be top down parsing in this one. Okay, in the next page, when we can see, you will have a bottom up parsing. So only two types of things only we are going to learn. So second unit also, there is two options. One option you will be getting a problem in top down parsing, or else you will be getting a problem in bottom up parsing. These two things only will happen. Okay, and in the case of third unit, when we have to concentrate, when we were telling, it will be the continuation of this one only. Okay, so in this we will be learning some things, parsing techniques here. The continuation of this parsing technique only will happen here also. There is something, another parsing, that is called as shift reduce parsing you will be learning. Okay, then there is another thing called as LR passes. Okay, so it is actually the continuation of this one. So here you will be learning top down parsing, and in bottom up parsing you will be learning about the recursive design parsing. Okay, and the continuation of the bottom up will be shift reduce parsing and LR passes. So if they want to ask some questions, mostly they'll be asking in shift reduce parsing, or it will be asked with an LR passes. But it is not the same like second unit. In second unit we have only two type of problems, as I said, so it will be very easy. In third unit there are four types of problems. One is shift reduce parsing, and in LR parser itself we have three types. Okay, in LR parser itself we have three types, but you don't have to worry about this, because when we start with the first type in LR parser, it will be a continuation of the first to second and the third. So obviously it will be only two type of problems. One it will be shift reducing, another one is about LAPASs. Okay, so mostly you will get problems in the second unit as well as in the third unit. Okay, and the fourth unit you have problems. Okay, but it will be a very simple problem only, so you can do it. It will be like you will be doing it in a table, so it will be mostly easy only. So if they want to ask a question, so they you will be asked simple problems in intermediate code generation. Okay, you have to find out the quadruple, you have to find out the triples and other things. Okay, that problem alone will be one thing. Along with that, we have a theory part. Okay, so in theory part, you'll be learning what is case statements, how the boolean expressions will be written in intermediate code generation, how the procedure calls will be written in intermediate code generation. All these things you'll be learning in the fourth unit. So if the question has to be asked, they'll be asking in quadruple, triple, and other things. That will be one problem. Or choice, they will be asking a theory part, how this intermediate code generation is done for a particular programming part. Okay, so that is about fourth unit. Fifth unit, it is purely about the code optimization. We will be learning how all this codes has been converted to the intermediate part. How we are going to optimize the code only, you'll be learning it in the fifth unit. This is also will be a theory only. But don't think that theory means how you used to learn in the theory paper. You can just write the theory part. This theory, if you are going to understand only, you can write this theory. But this both these things, if you understand only, for example, I will be giving a snippet of code. You have to write the theory part for that particular question. So in this case, you should understand how this intermediate code generation has been done and code optimization has been done. Okay. So in code optimization, we will be learning two optimizations. One will be loop optimization. Another one is peephole optimization. So this mostly it is theory only, but you should understand what was happening there. Okay, and the last part of this fifth unit is going to be the continuation of the optimization only. Here I have shown something called a symbol table. You can you have a symbol table here. So we will be learning code optimization in the fifth unit, right? It is a continuation of that. We have something called a symbol table. It will be so it will be the continuation of that. So all these phases of compiler is related to the symbol table. Okay, so this symbol table part you will be learning in the fifth unit later part. Okay, fifth unit later part you will be learning about this symbol table. Okay, so this is how it has been done. So all the phases of compiler was covered in the compiler design table. Okay, so first unit of this, second unit of this one. Okay, semantic you don't have to learn much. It will be easy only. And third unit is about intermediate, and the fourth unit it will be a continuation of this one, and fifth one it will be code optimization. A continuation of that one will be the symbol tape. Okay, so this is how this course is going to be executed. So now we will move on with this paper. The class is till 9:50, so let me start this part. So I was telling something called as compiler. So before moving on to compiler, so we should be knowing some basic thing that is called as, you should be knowing what is a compiler. We should be knowing what is an interpreter. Okay, and we have something called as assemblers also. Okay, all these things we will be learning. See, interpreter, general meaning you people know. Interpreter means always, for example, in general case, if we are saying, I am going to talk in one language. If someone doesn't know my language, someone will be helping me to convert it to the other one. Okay, so all these three things is going to help me to convert from one part to the other one only. Okay, so compiler also is going to convert from one part to the other part. Interpreter also it's going to be from one part to the other part. Assemblers also it is going to be from one part to the other part. Okay, but what will be the source and the target, that is more important. Okay, we have a source. Okay, we have a source. Okay, it will be converted to a target. Okay, so this is what we have to concentrate more. Okay, so we have something called as a source. It will be converted to another target one. So in the case of a compiler, okay, in the case of a compiler, always my source is going to be high level language. Okay, always my source is going to be a high level language. The high level language can be C, C++, Java, and any language. You can take any language you want. Okay, so it is going to be, the source is going to be a high level language. It will be converted to a low level language. It will be converted to a low level language. Okay, that is, it will be mostly of an assembly language or a machine understandable language. Okay, so it will be converted to a low level language. So compiler is about high level language to a low level language. Okay, so the same thing is the case for the interpreter also. But why there is a difference between a compiler and an interpreter, you should be knowing. Compiler, what it happens is it will be taking the whole program code. Okay, it will be taking whole program code. Okay, whole, the full program that you have given will be taken. Okay, and it will be converted to a low level language. Okay, and you will be executing the final code. Okay, this is what is happened. So you will get an executable code. Okay, for both this case, for the both compiler and the interpreter, you will be getting an executable code that you will be running at the final part. Okay, but in the case of compiler, you will take the whole code and you will convert it to an executable one. But in the case of interpreter, it is not like that. It will be reading line by line. Okay, you are going to read it line by line. So first line it will read. Okay, it will convert it and it will see whether there is any errors. If it is going to be an error, it will pop up at the first part itself. Then only it will move on to the second line. Okay, but in the case of a compiler, it will take the whole code. Okay, it will find out any errors is available. As a whole, it is going to give you the errors. Okay, as a whole, it is going to give you the errors. So this is the difference between this compiler and an interpreter. Interpreter, what is going to happen is it will read line by line and you will be converted to an executable code. Okay, but in the case of a compiler, you will take the whole program, you will convert it to an executable code. Okay, so my source and target, as I said, for compiler and interpreter, it is going to be the same. You're going to take a high level language and you'll be converting into a low level language. Okay, in the case of an assembler, okay, it is also going to convert only. It is just a translator only. All these three things, they come under a topic called as translators. Okay, it will be called as translators. So what will happen in the case of a translator? So all these three things, compiler, interpreter, assemblers, you can take it. Okay, along with that, we have other things also. I will tell you. So in an assembler, what will happen is you are going to take an assembly language. Okay, you are going to take an assembly language. Okay, and you are going to convert it to a machine code. You're going to take an assembly language and you're going to convert it to a machine code. Okay, what will be assembly language? You should be knowing what is an assembly language and what is a machine code. Machine code, always if you want to say, it will be in zeros and ones. Assembly code, if you want to say, if you have learned it in microprocessor, you'll be knowing how the assembly code will be. You will be having move, you have a less than symbol, everything will be there. I'll show what it is. Okay, so this is the main basic part in the case of a compiler. So compiler, it's just a translator only. what it is going to do, it is going to convert your high level language to a low level language. Same thing is happening in interpreter and assembly also. In interpreter, only difference between compiler and interpreter is you're going to read line by line and you're going to process it. Okay. In the case of assemblers, you're going to convert it from an assembly language to a machine code. Okay. So, uh, so this is what it has been explained here. You can see you're just taking a high level language and you're going to convert it. Okay. So this is the diagram. So you're going to read a particular program, okay, that is going to be a source language, okay, and you're going to translate to another language that is going to be a low level language, okay, that is machine understandable language, okay. I can type anything, whatever I want in a laptop or a system, okay, as a program. But if you want to compile it and if you want to run it, it has to be changed to a machine understandable form, okay, that will be a low level language, okay. So they are given whatever I have said, they have put it in a simpler words. Source languages, it can be C, C++. We have assembly language also, we have a machine language also, okay. So all these things is going to be taken into account. Always, if you are going to say about a compiler, it will be divided into main two parts. One is going to be analysis part, another one is going to be synthesis part, okay. You have an analyze part and you have a synthesize part. So in analyze part, what you're going to do is you will take the source program and you are going to split it, okay. So in analyze part, mostly you'll be having this lexical, syntax and semantic, okay. And in synthesis part, the remaining part will come, that code optimization and code generation I was talking, right? So synthesis about is you're going to convert it to a target program. So you're going to split it into two parts, this compiler. First one is going to be the analysis part. The next one is going to be the synthesis part. Okay, in analysis part, what you're going to do, you're going to do the first three phases of the compiler. You have lexical, you have syntax, you have semantic. Okay, that three parts will be done in an analysis. So what it is going to be doing in analysis part is you will take the source program, you will convert it to a particular intermediate code. Okay. So in synthesis part, that output will be given to the synthesis part. In synthesis part, what will happen is it will take the output of the analysis part and it will convert it to a target part. Okay. So this is how the model has been generated for compile. Okay. So this is what I was talking from the starting of this class. So you can see this one will be the synthesis part, and so this one will be the analysis part, and this one will be the synthesis part. Okay, the output of this analysis part is given to the synthesis part. So in analysis part, you have lexical, you have syntax, and you have semantic. Okay, and in the case of synthesis part, you have a code optimization and code generation. So this intermediate code generation is not going to play much role. Whatever you're going to get, it will be converted in between. Then you'll be moving on to the next part. But this all these phases we are taking, there is a common connection, that is going to be a symbol table. Okay, why we need a symbol table? For example, I want to do something, some conversions I want to do. Okay, so what I will do is I have something in my hand, I have to make it into another part. So what I do, I need a temporary bowl or something, right? So it is like a temporary one only. So this table, what it will do is whatever process you are going to do, it will be a temporary allocation, okay, temporary address generation and a temporary storage part. So that temporary storage will be happening in the case with the help of the symbol table. Okay, without this one you cannot do all this all this phases of compare. Okay, so in general only I'm telling in this class. In detail we will be learning in the next class. Okay, so what you're going to do in a lexical analysis. Okay, so let me show you. So in lexical analysis, what I will get is, I will first part, the input is going to be the source language, right? Source language can be of C, C++ or Java, anything. So So here I have taken only a specific line, that is a plus b star 10. Okay, this is has been taken as an input, but you will take a whole program. Okay, so then what it is going to do in the lexical analysis is you will split this particular program into tokens. Okay, you are going to split it into tokens. For example, a will be one token, plus will be one token, everything. Okay, so we are going to tell about identifiers, we have constants, we have operators, everything is a token. Okay, we have some special symbols that also will be a token. You'll be using a data type, that will be a token. Everything, each and everything is going to be a token. So if you consider this particular line, a is a token, plus is a token, b is a token, star is a token, 10 is a token, everything is a token. And result a, all these things will be identifiers, and this one will be an operators. So in lexical analysis, what you're going to do, you're going to take a particular program, you're going to find, you're going to change it as a tokens, and you're going to specify what type of token. For example, a, if I say, it has to be taken as what type of token it is. So it is, you will be mentioning a is an identifier. Okay, then you will be taking the token plus. Plus will be what? It will be an operator. Okay, the third part is going to be, you'll be taking b. B will be what? B will be an identifier. So like that you are going to mention in this case. Okay, so that is what lexical analysis is about. Second part, I will finish it in 2 minutes. Second part is going to be, you will get these tokens, right? You will convert it as a parser. Parser is nothing but a tree generation. We have done tree generation in FLA itself, but here the tree generation will be based upon the tokens. Okay, the tree generation, it will be based upon the tokens. So this one, you would have already learned something, a basic part in the data structures. You know how to create the tree, right? So same thing will be happening in the case of syntax analysis, but it should be very meaningful. So you should be knowing how you're going to convert all these tokens to a tree. Okay, that is why they call it as a parser. Okay, so the first one is going to be the lexical, the next one is going to be a syntax one. See, this is what I was talking about. We have taken this particular one. First step we have converted as tokens, second one we have converted as a tree. Okay, and the next one is, we would have converted into a tree. Okay, so it doesn't stop there. We have to find out whether that particular tree is having everything a meaning. Okay, without a meaningful tree, it is not going to be processed to this next part. So what you will do is, you get the tree, that the tree will be checked with the semantic. Semantic means meaning. Okay, so you will be checking whether each and every thing that has been there in the past tree has some meaning. Okay, so that will be done in the semantic analysis. Okay, the next one is this semantic. After doing the semantic analysis, it will be given to the intermediate code generation. In intermediate code generation, always we are going to convert it to a 3 address code. Okay, I'll tell you how this 3 address code will be done. So in intermediate code generation, this hierarchical structure, we are going to convert it to an intermediate code. Okay, so that will be there in the intermediate. So whatever code you have taken, it has to be optimized in the next part. So we will be having like thousands and thousands lines of intermediate code generation. It has to be optimized. Okay, so that will be optimized in the case of the code optimization. And the last one is going to be about this code generation. Code generation will be in between intermediate code and the optimization. You will give the intermediate code and you will get the code, then you will optimize the code. Okay, so this is what we are going to do. As I said, symbol table is common for all the phases. Without a symbol table, you cannot do anything. All these temporary storage parts will be done in the symbol table. It is just a data structure. You're going to collect all the records from all these phases. Okay, so with this, I will just finish it. And I forgot only one thing. Along with the phases of compiler, we used to do some error detection also, recovery also. We will do some reporting also. So that is what it has been mentioned here. So for that, we have another thing that is called as error handler. So the symbol table and error handler is a must. Okay, so you'll be getting some errors in this lexical, you will be getting some errors in syntax. In each and every phase you will be getting some errors. That errors will be handled by this error handler. Okay, so with this, let me stop and we will continue this phases of compiler in the next class. So let me take attendance. After that you can leave.